Hello, everyone. My name is John Sheehan. I'm an architect in the Windows and Devices group. And today we're here to talk about the desktop bridge. Now, before I begin, I want to apologize in advance because I woke up yesterday with some kind of cold or something. And so I may cough in the microphone, and my guess is that'll probably be fairly loud. I'm going to try not to, but if I do, sorry in advance. Before I begin, just show of hands, how many people actually know what the desktop bridge is? Good. Okay. So actually, there's a lot of people that didn't. Okay. So for some of you people, there'll be a bit of review material in here, but we'll also have a bunch of new content for you on things we've been working on in the last year. So first, a little history. Windows started all the way back in the mid 80s. We released the Windows 1.0 SDK. I think it was like 1985-ish. And really, that SDK set the programming model for the last 30 years. And it actually was great. I mean, there are, I believe, over 16 million or more Windows applications. And all those applications were written on, to this core API surface that we built. And then Windows 8 came along. And we decided, hey, I have an idea. Why don't we just get rid of all that and start over? I like to own up to it and say that was dumb. Because there were all these apps out there, and all these app developers who understood those APIs. They already had code that leveraged them. And what we basically said to them was, well, you're going to have to throw a lot of that away and start over. And that wasn't the best idea that we've ever had. So we've come along and we decided to build the desktop bridge. And the purpose of the desktop bridge is to really help bring all of that code forward to the modern Windows platform today that we call UWP. So what is the desktop bridge? The desktop bridge is a way for you to take your code, you go through a process of effectively repackaging it, and then it gives you a way to support the UWP platform. It lets you put things in the store, and it lets you target more of our devices, including how many people heard the announcement of Windows 10s? Yeah, so Windows 10s will only let you run apps from the store. Well, guess what? If you currently have a desktop app and you're deploying it from some website or something, you can't target users that are running Windows 10s. The desktop bridge is a way for you to very quickly and very easily start targeting those users while you can go ahead and modernize your application slowly over time. So why did we build the desktop bridge? Well, we did have this existing sort of app model, which people refer to as loosely as Win32, although that's very all-encompassing, including COM, including .NET, right? We had a lot of different APIs out there. But what we didn't really have is a coherent way to deploy those things to a device. So we basically said, here's a bunch of APIs. And then we said, you have to somehow get it on the device safely, make sure your app can run. If something goes wrong with your app, figure out a way to repair it. If the user wants to uninstall the app, make sure you clean it up, but don't break the device. And what ended up happening was it made Windows, and it made Windows users unhappy, right? Because you constantly had these situations where you would start installing applications, and there would be things like DLL hell, there would be things like an app would work today and stop working tomorrow, and it just really is not a great place to be. And also, you'd have things where you would point your users to say, hey, go install this, they double click on it, they get an elevation prompt that they have to say yes to, which basically means, do I trust this app or my system to run this code without any restrictions, right? The moment you get that dialogue and you say, do you want to install this, and you say yes, good luck. And this is, just so you know, this was our fault. Like, we did not have a model for you. And so, we did all kinds of things that or we didn't do all kinds of things to really help you developers build safe, easy to deploy applications for your users. And so the AppX, or the UWP app model, was our opportunity and our chance to go and fix all of that. So if you go and build a UWP app, you do not build an installer. Right? You don't build an installer. We have that for you. You just declare whatever it is about your app. You can just do that in Visual Studio. It's really simple. When you're done, you can hit a button. We spit out the package for you, and it's fully declarative, and it's fully safe. It doesn't require elevation. It won't cause the system to rot. It won't cause DLL hell. It won't do any of those things. And we really love that about UWP apps. But on the other hand, we still had all of these existing applications. And we wanted to be able to give the users that same safe, reliable experience, even with desktop applications. And so that's one of the reasons we built the desktop bridge. The other issue that we had was for you developers. We started building all these cool new APIs in Windows, and we built them for UWP apps. So you can have live tiles, and you can do WNS notifications, and you can do, you can integrate into the file picker, you can integrate into the share experience. There's all these really cool things you can do if you have UWP app, right? You can't do them if you have an old desktop app. And so we wanted you developers to not have to go and rewrite all your apps in order to start taking advantage of the platform that we built. So that's another reason that we did it. And the third one was, we're starting to release all of these other kinds of devices, right? We have Xbox, and now we have HoloLens, and there's IoT, and more and more have been coming from Microsoft. And for those devices, you can't target them, right? How many of you have seen like the Surface Hub, the big screen, right? Really cool device. We have them in a lot of our conference rooms at Microsoft. They're really amazing. You can't run your apps on that. And so we know that over time, you're going to want to get your apps to UWP so that you can target more and more of your customers in more and more scenarios. And so the desktop bridge is intended to help you do that. So I want to talk a little bit about how it works. Now, I'm going to initially talk about the desktop app converter. It's a tool that we released that allows you to take your initial installer and convert it into an AppX effectively automatically. It is not your only option. I'll talk about it here, but in a few slides I'll talk a little bit more about there's a whole bunch of other options out there now. And by the way, just so you know, I spoke about this last year, and I don't know if any of you were in that talk, but last year, the desktop bridge wasn't even in the bits we gave you at Build. We had a very small team. They worked really hard. Since we released it, which was what, about 8 months ago, we have gotten huge interest. Like it's been a little bit overwhelming because some of us have to participate in the process of developers having questions and stuff, and the response has just been overwhelming. And I don't know the exact number because I've stopped trying to count them, but I think in 8 months we're getting close to like 1,000 high quality apps in the store using the desktop bridge. So let's talk a little bit about the converter. The desktop app converter, like I said, it's this tool that we give you, and what it lets you do is it lets you run your installer effectively from the bridge's standpoint once. You run the installer one time, and what we do is we take your installer and we stand up a container. I don't know how many of you are familiar with containers, but containers are this new technology that we've shipped in the last year. I think actually in the last year. And it lets us stand up an instance of the operating system, kind of like a VM, but not as heavyweight as a VM. It lets us stand up effectively a new user mode instance of the operating system, and then it lets us run processes inside of there. And as stuff is running inside of there and it's making changes to the operating system, it actually captures those changes so it doesn't dirty the real system. So we stand up one of these containers, and then we run your app inside of it, we run your installer inside of it. Now your installer is going to go and it's going to do all the horrible things that installers usually do, right? It's going to go edit the file system wherever it feels like. System32, we told you could put files in System32. It was a colossally dumb idea because Once people start putting all those things into System 32, pretty soon people start editing over each other's files. That's one of the flavors of DLL hell, right? But that's fine. With the desktop bridge, it's totally fine. Your installer can go write stuff into System 32. It's safe. It can go and write all over the registry. Registry, another interesting technology we delivered. It's not that it's necessarily a bad technology, because giving you kind of a high-speed database to store settings and stuff, that's not necessarily a bad idea. But we gave you APIs that just let you edit anything. And your installers could just go and edit anything. And if you've ever gone on MSDN, for example, and you go and do a search for some problem, and it says, oh, there's a solution to that problem. And it says, in order to solve this problem, you have to go update this registry key. And then there's this big warning, right? And the warning says, caution, editing your registry may cause your system to never boot again, and bad things can happen, blah, 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 blah. Anyway, here's how you go edit your registry to go fix this. And so we've learned over time that it was probably not the best idea. And on top of that, it also has another side effect that most people don't realize. Everything that gets written to the registry, every item that gets written, increases the size of the hive file just a little bit. And when the system boots, it has to load some of those hives. And then when you log in, it also has to load those hives. And the bigger those hives get, the slower the boot gets, the slower the login gets. And usually people refer to this thing as like computer rot. You buy a computer, on day one it's really fast. And 2 years later, it's the same hardware, and I don't know what you think, but CPUs don't get any slower. They run at the same speed. But all of a sudden, it boots slower. It logs in slower. Different operations are slower. And what's really happening under the covers is that we're just loading more and more junk, and it actually gets loaded into kernel memory. And so this is another case of those things that probably aren't great ideas. I'll give you an example. How many of you ever installed the Enterprise Edition of Visual Studio? And you were just like, you know what, I'll take everything. I'll take one of those and two of those. Sure, SQL, maybe I'll do it, I don't know. So you do everything. The last time we checked, and now this data is a few years old, so I don't know if it's better or worse, but at the time, does anyone want to guess how many registry entries that Visual Studio put into your registry? So someone said 1,000, someone said 1,000,000. 1,000,000 is really close, 1,000 isn't even remotely close. So it's about, at the time, it was about 750,000 entries. And every time your system booted, it had to load all of that. Every time. Even if you weren't using Visual Studio at that time, you just wanted to give a presentation, it loaded all of that stuff. So yeah, let's probably do our best to try to keep that stuff out of the system registry. And that's one of the things that the converter does. So in the kernel, we're sitting there inside this container, and as your installer is going and doing that, we're catching it all. And then we package it up, and we put it into a separate place, that's just dedicated to your app. So now, if I use the desktop bridge version of your app, and I go and install it on a system, it doesn't do any of that. So the system will boot at the same speed it did before, it'll log in at the same speed it did before. Now, if I launch your app, well, now it's going to have to load that stuff because you actually need that data. But at least it's pay for play. The system will always boot at the same speed because we will never be loading your app during the system boot. When the user logs in, they decide to run your app. Now they take the penalty for whatever resources your app uses. And so anyways, once your installer's done, we can then look at it and say, here's all the files that were laid down. Here's all the registry entries that were laid down. And then we can go and interpret them. Right? We can say, OK, I see that you put a link file on the start menu. Well, the modern version of that is called a tile. So we'll generate a tile for you, and we'll even take the icon for you and put it in there. We'll see that you went and laid down a bunch of registry entries for file type associations or COM objects or whatever. We can go and interpret all of that and figure out what the modern way of representing that data is. And for all the stuff you put there, we can just kind of preserve it just in case you have a bunch of random registry entries that you write for your own purposes and you want to edit those things. And the reason that we do this is because we don't want you to have to change your code. And we really mean that. Now, don't get me wrong. Sometimes you're going to have to change your code. Sorry. But usually you're going to have to change your code is because you're not following best practices. It is exactly all the best practices that Microsoft decided were best practices, and then we never told you they were best practices. right? You know, isn't that great? Like, we're like, oh, you shouldn't do that. And there's nowhere on MSDN that tells you not to do that. We gave you the APIs to do it, whatever it is, and then you're like, oh, I wasn't supposed to do that. Like, for example, apps. Like, your apps really, honestly, should be running as the user. They should not be running as the operating system. Why? Because, you ever have a bug? I have. If you have a bug, and you're running as the operating system, and that bug gets exploited, the system is gone. It is no more. It is completely under control of the hacker. And we kind of think that's a bad idea. And so we don't want you to do that. And so with the desktop bridge, if you have code that's currently running as the system, you're going to have to change that code to run as the user. But hopefully, most of that code will still just continue to work. You'll just run with a different security principle. So once we're done analyzing everything, we can now package it all up, and now we create an AppX package. And an AppX package is exactly what we use for UWPs as well. It's basically a glorified zip file with a manifest file inside of it. The zip file is the payload, and the manifest file describes how your application integrates with the operating system. So if you have a tile, it says you have a tile. If you have, you know, some kind of public COM object, which, by the way, is a new feature for the creators update. We didn't support this before the creators update. But now you can actually have public COM objects that you expose to the system. And other apps can go ahead and co-create instance those COM objects, and they'll continue to work. And so with all of that, we package all of that up. And then now it's just up to you to go make sure that your app still works. Now, like I said, as we've seen that, I don't know the current data, but the last time I was involved in it, it was about 2/3 of apps like just worked. And the ones that needed changes typically had to make very small changes. So the technology is pretty good. And given the fact that it was a very small team, like, we're very proud of the amount of app compat we've been able to preserve. Because our goal is for you to keep using your existing code and keep leveraging your benefits. And I'd much rather see you spend time building cool new features for your users than trying to care and feed the system because we decided, by the way, true story, at one point in the Win 8 timeframe, we decided not to support WinSock. We had all new networking APIs. And we said, you know what? You need to go rewrite all your networking code to not use WinSock and use the Windows networking, blah, blah, blah. And when you were done, you had exactly 0 new features, which I'm sure it would make your users really psyched. You'd have to retest all of your code, and I guarantee you that the API surface was different, so you'd have different kinds of bugs. And so now we're really doing our best to say, as long as there isn't something inherently wrong with the API, we'll try to bring it forward. But in general, you're going to need to test, and you're going to need to just make sure your app works. And then once it's done, you can publish it. Now, our expectation, and actually our experience, is almost all developers, or actually all the developers that I've talked to, are publishing to the store. And they're publishing to the store because it gives them a lot of benefits around distribution and visibility and all of that. And it also lets them target things now like the Windows 10 S version of Windows. And so, but it is still an AppX, and so your users can still decide to sideload your package if they wanted to. But in general, you know, our expectation is most of you are going to go to the store. So we shipped 8 months ago. What happened? It turns out that we got huge interest, and we had a ton of people that were really excited. And here's just a few of them. And one of them was so excited that they actually went around and they built their own video describing their experience, taking their app and bringing it to the store using the desktop bridge. I don't normally have videos in my talks. They're usually for keynotes and whatever. But I was so impressed by the work that these people did that I have to show it to you. So let's look at it.
Evernote is my external brain. It's how I stay organized and get work done. Now that the desktop app is available on the Windows Store, you can be even more productive.
We recognize that knowledge workers and people who value productivity don't just work in a silo. They use hundreds of tools every day, and they rely on Evernote to pull it all together and put everything in context.
We know that the vast majority of our users use Evernote both in a consumer context and in a professional context. But 90% of the time when they're using in their professional life, they're using on Windows. So when we talk about winning in the workplace, we're thinking win on Windows.
Some of the key benefits that I've seen since using the desktop bridge were the ability to leverage some of the new Windows 10 features that we were not able to before, things like live tiles and notifications, and we hope to do more in the future.
We use live tiles so that you can stay informed in terms of when you're getting notifications or work chats. Being able to bridge the gap of not just having Evernote closed, but knowing when to open it has been a delightful moment for many of our users.
We've worked with Microsoft on Outlook, Outlook Mobile, Edge, and we're looking forward to what's next, such as deeper integration into Office.
And we're pretty confident that about 1 in 5 of our users is attaching Office documents to Evernote because they're trying to do more with their ideas. And that means seamlessly working in both of those products right now.
One of the great things about having the app on the store for us is that it means our users are always up to date with the latest and greatest that's being produced from Evernote.
When we put a new release out, which we do fairly aggressively, this will happen very quietly.
Evernote for Windows first launched in 2005, and we've been improving it ever since then. It was really important to us to be able to take advantage of the best that Windows 10 has to offer without abandoning our users who may have been on Windows 7 or older operating systems.
I'm David Connick.
I'm Andrew Malcolm.
I'm Seth Hitchings.
I'm Chantal Leonard, and I build for Windows.
All right. So yeah, I really want to show that to you because honestly, getting to talk to these developers about their experiences with the desktop bridge has been like great for my soul. Honestly, they love it. They've really been leveraging it the way that we expected them to. And a lot of these developers, as they said, they're already starting to add these cool new features that they couldn't before they moved to the bridge. So we shipped 8 months ago, and since then we've had another release in Windows, which was the Creators Update. As part of the Creators Update, we added a whole bunch of new extension points that we now support. There's a bunch of shell extensions that we added. One of the really big ones is what we call packaged public COM or public packaged COM. And that, as I kind of alluded to before, it allows you to define COM objects that get registered with the system that other apps throughout that aren't part of your package can go ahead and they can co-create instance and they can use them. There is one key thing, by the way, and this is something that you will hear about again and again with the desktop bridge, is extensibility, when we expose it, is always out of proc. So these COM objects that you're going to expose, they're going to be out of proc COM objects. You can't go and say, hey, I want to register a DLL, and it's going to get loaded into random processes. And just so you know, we didn't do that because we were lazy and didn't want to support in proc. We very intentionally decided not to do it because it is one of the #1 reasons that users have instability with apps and with the operating system. So Explorer.exe, you know what? I see it. Now I run internal builds of Windows every day. I take the build every day. But seriously, it crashes on me multiple times a day. It crashes so much that we build features to make it restart faster, to make it good at crashing. Right? So Explorer.exe is probably one of the best processes in the world at crashing. And unfortunately, there's really not a lot we can do about the crashes because it's not even, in 99% of the cases, it's not even our code that's crashing. There's someone else has defined some extension point, some shell extension. We load their code. We start calling their COM interfaces. Something goes wrong in their code. And because it's running in the same process, it just takes it down. And so we have to do something about that. And what we've decided to do is to just say, in proc extensibility, it did make a lot of sense in the 80s and probably even through the first to late half of the 90s. But at a certain point, the system got enough resources and the CPUs got fast enough at doing context switches that loading the code inside the process is just not worth it for us. The biggest challenge that some people run into is that their interfaces were designed kind of poorly because they had very fine-grained operations that you do thousands of operations a second. Normally, when you're talking about extensibility, you should really think about not doing that. And so being out of proc will help you understand where you have those kind of designs, and you can start updating your interfaces. One of the last things that we did was actually we added support for WAC, because when we first shipped, the WAC was not able to actually figure out from your desktop binaries whether it was calling undocumented APIs or not. And so we have since released a WAC that actually makes sure that you're only calling publicly documented APIs. We're actually doing this to be helpful, because if you're calling private APIs, I want to tell you, I mean, I work in Windows every day. If an API is private and it's not publicly documented, we make the obvious assumption that we can change its behavior and even change its signature at any moment. Because it's private, we're the only ones that are calling them, so we can make the change and update all of our code and then ship again. And if you're taking advantage of those things, then what's going to happen is we'll ship the update, we'll break your app, your users will have a bad experience, and they will either blame you or Windows or both. And so we don't want that to happen, and so now we're going to make sure that the APIs that you're calling are the ones that we're going to support and make sure that your app continues to work great. One thing with the Creators Update is now, I think we just announced it last week, we're bringing Office to the Windows Store. So the real full Office, the Outlook and Word, Excel, PowerPoint, they're all coming to the Windows Store. And moving forward, that's where you'll go if you're a Windows 10 user to go acquire Office. Just to make an obvious statement, Office has not decided to deprecate support for Win 7. They still support Win 7 and Win 8 and all of the older OSs. But it's the power of the desktop bridge that allows them to keep that same code, that one code base, which is Office, and go ahead and also bring it to the store and bring it to Windows 10s and all of those platforms that we support. So now I want to take you through the process that we expect you to go through with your app. And basically this process will take you from the very beginning when you first decide to do the conversion process all the way through till you're a full UWP. And so step one, I already started talking about, which is convert your app. And some of the very interesting things that you're going to get is that you get to throw away your installer code, unless you still have to support Win 7, right? But if you don't have to support Win 7, then you can go ahead, you can throw away your installer code, and even better, your users can safely decide to install your app, and they don't even need to elevate. Like, I don't know about you, but like in my household, my daughter does not get admin privileges on the machine, right? And I see a lot of people nodding their heads, right? But I constantly get this, Dad, can you come upstairs and punch in your pins so I can install this thing? And I have to go up and look at it. I'm like, what are you installing? Most of the time it's a game. Most of the time it's a fairly reputable game. A few of the times it wasn't, and I told her this is probably not a good thing to install in the system. But if you're in the store, if you're using Centennial, or Desktop Bridge as the code name was Centennial, you don't have to worry about that. You install, there's no admin prompt. There's no danger to your system. A non-administrator can install the apps and use them fine. And you can feel completely safe that that non-admin user is not going to have any more effect than if they just downloaded something and ran it locally. So since we released, we have had a bunch of our partners that build tooling for installers come along and add support in their tools for Desktop Bridge. And we actually see this as the best way to go about converting your app. Using the converter's fine. It's kind of cool tech. You get to think about filters in the kernel and stuff. But in reality, you just want this to be part of your build process. You want to just say, hey, I want to support Desktop Bridge, check a box, push a button, and your build system was pushing out your installer already. It can now keep pushing out your regular installer. And now it can also push out a Desktop Bridge package. And so here are some of the partners that we have that are going and, or have already gone and done this work. So if you use any of these, like by the way, FireGiant is an add-on pack for Wix. So if you use Wix as your installation technology, you can go to FireGiant and get a solution for generating Desktop Bridge versions of your app. And so if you use one of these, then that means like you don't have to do hardly anything. You just go, I mean, obviously you probably have to be on the latest version. If you're on a really old version, you'll probably have to upgrade. But once you have the new version that supports Desktop Bridge, you can go ahead, check the box, push the button, and it'll spit it out, and then you can test it and run it. And once you make sure that it works, you can then make that part of your daily build process. And now, with that same code, you're spitting out an installer that works for Windows 7 and before, and then you're also spitting out this Apex package. Also, Visual Studio has been slowly adding features to support the desktop bridge. And they're currently working really hard to make it super easy that if you just have a Visual Studio package, you don't even, maybe you're not even using any of these. We do actually run into a lot of apps, that don't have installers, which is kind of interesting. But they're like, well, all I do is I tell my users to download the zip file, unzip it, and then double-click on the exe, and that's how my process works. We've done work in the converter, by the way. We didn't support that in the converter when we first shipped. We've now done work to support that in the converter, and we'll show you that in a minute. But Visual Studio is also adding more and more support to make it really easy to take your existing desktop app and quickly convert it, or quickly generate an Apex package from it. So I'd like to introduce Payman. Payman is going to show you a couple of instances, or a couple of different ways to convert your apps.
Yes. So starting with Desktop App Converter, I've done some homework right now. I've set up Desktop App Converter. We have great documentation on MSDN, as well as a video walkthrough in Microsoft Virtual Academy. So I won't go into too much detail on that, but just to show you, this game that I'm trying to convert right now does not have an installer. So instead of the installer argument, I'm just going to pass the path to the payload of my game. And a couple other arguments that I'm declaring here is the name of the executable, where I want the files to be, as well as passing the package name, publisher name, and the version number. And a couple of flags at the end, I'm adding make Apex and sign, so that's going to actually create the package for me and sign it as well. So what Desktop App Converter is going to do now is going to do some prerequisite checks, make sure we have the right SDK installed. It has access to sign tool, make pry, make Apex, all those tools. And once it does that, it's actually going to create the Apex manifest for me. Now, before, like John said, we would have to do this manually, but this is a new feature that we added in Desktop App Converter, so it will do all of it for you. It's going to create the package for me now, and it's going to sign it now. Desktop App Converter is going to create a test certificate for me and sign it with that. I do have a choice of not using that. I could use my own production certificate and sign it with that, but in this case, I'm just going to, for the demo purposes, I'm just going to use the test certificate, which I will need to install, which I will show you in a second. So just about done. It's going to point me to where the files are. I have it over here. So it did put the certificate for me here, so I will go ahead and install it. Again, if this was a production certificate, it was probably already trusted, so I wouldn't need to do this. There we go, and what I can do now is I can just double click on this and install it. Now see how fast this is going.
Okay, so if this was your app, we actually just ran the converter for all of that. That's how long it would take you to go through the conversion process and get your Apex package. It takes just about as long as your installer does, plus a little bit extra to do some processing.
So I can either launch it from here or go to my app list and launch it here. And it should come up. There we go. Not going to go into gameplay. Another thing I just kind of wanted to quickly point out is that this game is already in store. The publishers were able to easily come to store using our Desktop App Converter.
So there we go. All right, so what else do you got for us?
So the second way I'm going to show you is through Visual Studio. What I have here is a Windows Forms app that's talking to a simple database. It's a product inventory type. And what I can do is I can add a project, a packaging project to my solution, which will give me all the great capabilities of a UWP project, where I can click here and easily integrate with the store and create an Apex package right there. And another thing I want to point out here is the package manifest designer. So this is going to easily allow me to generate my assets, declare any capabilities I need, or any extension declarations that I need to add. So now I can just deploy using this packaging project, and I will have my app here. Now it's running as a Windows package.
Very cool.
One thing we should call out, I didn't show the packaging project. It is a bit more involved right now to do it, but as John mentioned, we're going to make it a lot easier. But we do have a great MSDN document and a video walkthrough of how you would go about setting that packaging project.
Thanks. There it goes. OK. So now, let's assume you've gone through the process. You've ran the conversion. Your app works. From a functionality standpoint, it has the same functionality that it did before. So basically, the benefits you've got is you're in the store now, your users have a safe experience, blah, blah. But you haven't really added any features yet, any real features that users would understand. And so one of the really great things about the desktop bridge is the moment that you run through the conversion, your app now has what we call identity. And so in the old world, there were just a bunch of EXEs and DLLs and files on disk and a bunch of registry keys, and the system knew nothing about what any of that meant. When we say that we used to have an app model, that's being very generous. We basically had files and registry entries, and we knew how to call create process and load library. That's pretty much all we could do as an operating system. And now we actually understand the identity of your app. And with that, you can do things like start to call all the new APIs that we created. All those APIs expected to understand the identity of what the app that was calling it. So if you say, hey, I want to update my live tile, you just type the line of code that says update my live tile. And the system knows who you are, it knows what your live tile is, and it knows how to figure out all of that. That also prevents other apps from updating your live tile, right? If we hadn't done that, we would just have to trust apps that who they were. So an app could randomly say, hey, I'm Outlook, update my live tile, and we would have had to do it. But now that we have identity, we let you call those APIs. And there are some really exciting APIs coming, and we're about to show you one of them, that really show the power of being in the store or being on the desktop bridge will enable you to do.
So what I've done here now is I've added a button here to do some purchasing. And the code is here. This is where I'm calling the payment request APIs, where I'm passing all the details of the purchase, the merchant info, the types of payments that I want to accept. I won't go into too much detail on this. There's a great pre-recorded talk on how to use the payment APIs, payment request APIs, and also the team is going to be the featured team on Thursday at 12:30 if you want to go talk to them. So let me just show you how this works. Again, I can deploy using my packaging project. And there I have it. Now I have this purchase button, so I can click any of these guys and try to purchase more of it. This is going to tie into my MSA, so it already has my information. I'll pick my address and my shipping method. This here, I can see my details on the order, so I can just go ahead and click pay, add in my CVV, and it should, yeah, there we go. We successfully purchased that. Simple as that.
Yeah. So here's an API that you can't currently use today if you're not using the desktop bridge. And in a few lines of code, you don't have to stand up a back end to take credit cards, to do all of those things. You can literally use our payment APIs from within your app, assuming that you have identity, so we know who's actually calling them. And now you can use that. And we think that's really interesting. We think it's great. And there's a whole ton of APIs that you can now start calling the moment you've gone through that conversion process. And so now you're really adding features to your apps that your users will love and that you couldn't before. But there are a bunch of things that you still can't do just from inside your app. In other words, you can't just add a few lines of code and call it a day. There are certain parts of our system where we let the app integrate deeply inside of the operating system experience. Like, for example, like the file picker. So if, let's say you have an app and it's kind of like a Dropbox where you store a bunch of APIs in the cloud for the user, and you want to make sure that they have easy access to those APIs regardless of which app they're using to get at them. Windows has the ability for apps to plug into the file picking experience where you get your own entry on the left of the dialog. They can click on that, and we give you the power to go and put all the pixels in and decide what experience you want, how you want to represent your data to the users. And that's something that we can only do from a UWP process. And we've had lots of questions like, well, are you eventually going to try to enable my HWinds, Win32, NT user Windows to kind of plug into that? The answer is no. And we're not going to do it because it turns out that it's extremely hard to do. And on top of that, we don't have a way to do that and not also probably break your code. I don't know how many of you understand or know what NT user is. It's basically a thing that lets you call create window. Like create window, that's NT user. Inside of Windows, we like to think of NT user as the gateway through which all hackers come into your kernel. It kind of seems to be the #1 place that people attack when they want to get into the Windows kernel. And so it is the reason that we haven't tried to bring it to UWP. Because first of all, its roots are all the way back in the 80s. And at that time, there was no such thing as security, right? In the 80s, security wasn't a thing. You ran everything. Everyone was an administrator. All the code ran together. It was completely cooperative. If the code was on your system and was running, it was assumed to be great. The world has changed a lot since then, and it's been really, really hard for us to try to harden things that were designed assuming that security didn't exist. And so what we need you to do is to actually start to modernize your app. Start to use XAML or HTML and JavaScript, or if you're a really fancy developer, you can do DirectX. But start to program to our UWP API surface for windowing. The great thing, though, is that we've made it really easy, because you don't have to now convert all your code over at once. If you want to do just that file picking experience, you can go ahead and you can basically create a new project in Visual Studio. You can create your little XAML or HTML or whatever UI that you want to do, write that code, and very easily we give you a channel to talk back to the desktop bridge part of your app. And so we allow you to set up a communication channel and do bidirectional communication with it. And so you can literally just build the new feature, and then you can go ahead and implement it, talk back to the desktop bridge part of your application, and call it a day. And this is part of our philosophy. Our goal for people to modernize their apps and to bring them forward to UWP is pay for play, right? We want you to get a proportionate amount of value for the amount of code that you have to write. If we said, great, you want to integrate into the file picker, rewrite your entire application, and then you can have the file picker feature, like no one would do it because people aren't crazy. And so we want you to be able to do it pretty easily, and so this is the philosophy. And so now Payman will show you an example of doing that.
So before I actually show you the new XAML part, I want to add one more UWP component here where I want to run the task in the background to perform some maintenance task. Now, I want it to be in the background so it will continue running even if the app is not running itself. So what I want to point out here is in the manifest, what I've done is I've declared a background task extension and pointed it to my background task. And what I've done in my WinForms app is I'm doing the registration here. So I'm calling out what the maintenance task is, and I'm, again, pointing it to the entry point of that background task. And this is where I've actually implemented that, where it's just simply going to show a toast, letting the user know that I'm running some background processes, and it's going to do the maintenance that it needs. So let me just show you how it works. I'm going to go ahead and deploy this. And this background task actually triggers every 6 hours. So to show you guys, I'm just going to go ahead and attach it to my debugger. Oops. Let's try that again.
Wah, wah.
No, we can make it work.
OK, like all good live demos, sometimes things can go wrong. We'll try it one more time. If it doesn't work, we'll move on.
There we go. And so from here, I can actually go ahead and trigger that background task. Now you will see my toast. And if I open Task Manager, I should be able to see my background task running in the background. Now notice if I went and closed my main app, this will continue running as long as it needs to perform the tasks that it needs. And that's it.
Yeah, so here's an example of leveraging the new ways that we've defined so that you can have your code running when it needs to, not constantly running, right? With desktop apps, typically you had two choices. You either ran all the time or you didn't run all the time. And as we all know, you start installing apps. The other thing, or one of the other things that ends up causing computer rot and causing your logins to slow down is you install all these apps, you log in, and what happens? They all start running, right? Because obviously that app is the most important thing in the world, and it needs to run right now. And the really funny part is in 99% of the cases, it needs to do something occasionally, right? But we never really had a good way, a good supported way of doing that. We had some things like scheduled tasks that were really hard to do and just never caught on because people were so used to just going and just running all their code all the time. And so now we've defined this new background task model. And here's a way that your app can start taking advantage of that now, start modernizing your app, add new features, and also not be so resource intensive and resource heavy for your users. And so I don't know about you, but I go through and I will use something like, there's a bunch of different tools out there for finding things that are always running. And I go through and I just turn everything off. And I know that these developers want to be able to engage with me, which is why they set their code to run all the time. But guess what? I'm not willing to pay a gig of RAM to run 20 apps in the background because they occasionally want to interact with me. And so you can now start going away from that and start using a better way to help your users. All right, so then our expectation is you're going to start moving more and more of your functionality into this UWP process that you created previously. And so at this point now, once you start doing that, you can start actually using XAML for the pages that you move into this process. It runs safer, which means right now if you have a bug in your code, well, the user's probably in a lot of trouble. If you're running inside of an app container, if you have a bug, well, your app has a bug, that's not good, but at the same time, the user and the system is protected. And so you can go ahead and start to do things like have a subset of your features run everywhere. So one thing that we've seen developers start to do is to say, you know what? My desktop app has 20 features, and that's great, and I love all 20 of those features, but there's a subset of those features that make sense everywhere, that would make sense running on a phone, would make sense running on Xbox. And with the desktop bridge, that completely works, and it's designed that way. Basically, inside of your manifest, you can define all of the different things that are universal and run everywhere, and then you have the pieces that are defined that just run on desktop. If you deploy your app on any other device besides desktop, those desktop pieces get ignored, but all the rest of it comes along. And so basically what you've done at this point is you've said, okay, I now really do have a UWP. I still have some desktop-specific code because I haven't been able to move that yet. But it doesn't matter. I can actually deploy this across all of the different devices that Microsoft supports. And so let's have Payman show us doing that.
So this is where I've actually moved most of my code into this UWP component, where I'm actually building a brand new UI using the Telerik data grid controls. But I still have my data access layer in a Win32 component. And I'm connecting the two pieces via this background task over here. So again, if you look at the package manifest, you'll see that my main entry point is now a UWP. But what I'm doing is I'm declaring this full trust process extension, which will allow me to talk to the components that I've not migrated yet. And this is the app service declaration that I've done. So just quickly, this is the new UI that I've created here. And the code, what happens is on the onNavigated2 event, we launch that run full trust process, which will then do the app service connection, and we get access to our data. So I can just show you what that looks like. I can go ahead and deploy this guy. And launch it. So I made that Win32 component a console app just to visualize it for this app, but for this demo. But this will usually be a background task. And this is my brand new UI. All these great new UI features were built in. I did not have to do any coding for that. And this now does feel like a modern app. And I can do a lot of cool things with it. I can filter with it. I can pivot my table based on different metrics and things like that. Thank you. Thank you. Take that.
So for the developers that I've spoken with, the reason that they end up at step 4 for a while is they have some amount of code that they could rewrite and make it fully UWP compliant, but they just don't have time to do it right now, and they decide, you know what, I've got other things to do. I've got to go build features. I don't really want to do that. And if you think about it, the reason that they're having this problem is because of that decision that was made all the way back in Win 8, which was we have 480,000 APIs or something available in desktop. That's including Win32, COM, .NET. Like if you sum all that up, it's about 480,000 of them. And we decided that you could use practically none of them. Right? And so that means that all that code that you had that was calling one of those APIs isn't, you can't bring to UWP until you rewrite it to use some other API that honestly probably does exactly the same thing, but it just, you just have to call it differently. And so what we've been doing over the last year is we've been going through all of the data for all of the apps that we have metrics on, and figuring out what are all the APIs that people really use. Because by the way, out of that 480,000, not all of them are actually particularly useful. Some of them, as far as we can tell, have exactly 0 callers, and some of them have like 1 caller. And so, but a lot of these APIs are APIs that are leveraged by common frameworks that you use every day or by your code. And so we're bringing as many of those forward as we can. We're also looking at all the .NET APIs and doing exactly the same thing. Because as long as the API isn't broken, like we can't support it on the rest of our UWP platforms. I'll give you an example of something that is broken and we won't be able to bring. It's what I mentioned before. It's end-to-user. You are not going to want us to bring that to future platforms because it literally just means you're unsafe. And so we really are doing our best to secure it as best we can on desktop, but not bring it forward. But other than exceptions like that, we're trying to bring everything forward that we can. I am in meetings 10 times a week probably, working with teams and talking about their APIs. Like for example, as of today, you cannot call create process. Not supported. There was a reason that it wasn't supported. And I've been working with the base team inside of Windows, the team that owns the kernel. And soon, we will actually be able to say that we're going to make it fully supported. Go ahead and use it just like you always have. Because actually creating processes is something that I think operating systems are supposed to be able to do. And so it's kind of crazy that we didn't have that API for you. And there's just thousands and thousands that we've been looking at. And so with all that work, we're really hoping to make this a very, very easy process to say, yep, my code runs here, I pick it up, I move it over here, and it runs here, full stop. For example, in that demo, we didn't actually show it, but the data that was coming to fill out those forms at the time was actually coming from an XML file. Why? Because we just did the demo quickly, whatever. But how many of you think that like the great place to store all your data is inside of an XML file? Yeah, probably not. How many of you people have ever used like SQL clients from .NET, right? SQL APIs? Right. That's where people store their data. Like it's, that's just what everyone does, stupid. And so we're bringing those APIs forward. We're bringing a ton forward. We're bringing all that we can forward. And we really believe that this process that I just described, we're going to make it easy for you, as easy as we can. We think it's going to be great. So I want to let Payman show one last demo.
Just one last thing. Now I've moved all my code from my data access component into my main component. So what I can do is delete this project, this component, and I can go ahead and, oops. Come on, Bishop. So let's deploy that. Now everything should run, same code should be running in my app container. No more Win32 code, no more app service. This will be a pure UWP. There we go. And there we have it. It's the same thing. And I can actually go a step further and deploy this on phone. Let me just quickly, I feel brave today, so let me just show that too. My phone here. Just might take some time, so.
And if the demo gods are willing, wait for it. Wait for it.
It's doing it.
Is it still deploying?
Yeah. It's
Okay.
trying to build.
Well, as you can imagine, this app that's now a full UWP will run on phone, it'll run on Xbox, and it'll run wherever. Can you switch back?
Let me just, it's going to take one more second. I really want to show this. There we go. Thank you. So, same thing, I can still do all the great stuff. I can complete my purchase, do all of that. And there we have it, a full UWP.
Cool.
Thank you.
All right, I'm going to blow through these last few slides. I was intending to leave more time for questions, and so I'm not sure how soon we'll be kicked out of the room, but I'll answer as many as I can. A few quick things. I talked about safety with the desktop bridge. Desktop bridge is not for system software. If you have an antivirus system and it has kernel drivers and it runs as an NT service and it can basically pwn the system if it wanted to, desktop bridge is not for you. You'll have to continue to support Windows however you have before. People worry that, oh, once I convert, therefore I can't support Win 7 before. Office is an obvious example of that. They're using the desktop bridge. They're coming to the store. They're still going to continue to support Win 7 and all their other platforms they've always supported. And basically, one last one that's been interesting is, hey, once I run it through the converter, I'll now run an Xbox. And could you literally imagine your Win32 UI trying to run on an Xbox and trying to use it with a controller? No, we do not do that. Xbox does not have all of the components that the desktop does that you might be using. Once you go over the bridge and you get to step 5, then you can run an Xbox, then you can run on mobile, you can run on HoloLens, you can run wherever. Our expectation is if you have a desktop app, we think that you should be using the desktop bridge. We don't really see any reason why you shouldn't, unless you're system software. And we have a desktop bridge booth over on the 4th floor, and you can go there and you can actually bring your installer and they'll convert it for you. So you can run the conversion, launch the app, and see if your app just works. And finally, there's some resources there that you can get at. You can see the rest of this after, and there's a bunch of other related sessions that you can look at. Please fill out your evaluations, and I'm sorry I only left a few minutes, but if anyone has any questions, please come up to the microphones because this is being recorded, and if you speak in the microphone, they'll be able to hear you, and if you don't, you won't.
So you guys have done a great job with phases 1 and 2, getting the runtime and the installation migrated.
Yeah.
But are you guys looking at doing anything for code migration? Because there's a lot of just boilerplate stuff. I'm thinking Clang Modernize, where you know about things like the networking API that you can change the code, or you know how to convert XAML or XML or MFC to XAML type stuff. Are you looking at code translation to kind of get us most of the way?
Well, so our goal is that you don't have to do code translation. Your networking code should just work. Oh, whoa, there we go. I flam my hands a lot. We expect your networking code to just work. As far as your UI goes, we've looked at a bunch of different things. We're talking right now, for example, about you to start to introduce XAML into your desktop bridge app. Thank you. So that you could start changing your code to be using XAML piece by piece. It's an interesting idea. I'm not sure how great we could do it, but it's something we should definitely keep in mind. Thanks.
So we already played with this desktop bridge functionality. We actually went the other way from UWP, and we needed some more functionality, and we used the full trust process, and we embedded that. But then in the end, it turned out that there are some requirements on your Windows developer account that you have to be enabled to publish those into the Windows Store. Can you talk a bit more? What are the requirements? Why is there this special review process, or what's the deal?
Sure. So yeah. So all we're trying to do is make sure, because your app is still running full trust like it did before, it inherently has more danger to the system than something that's running sandboxed in an app container. And so that process is just to make sure that these are coming from reputable developers, and that they are they're using the bridge as it is intended, right? We had people start to use the bridge, and all the app would do is you'd run the app from the store, and it would turn around and try to run the MSI. So
are you trying to review the code, or how do you trust the developer?
We actually have people. So we have people talk to the developers to make sure that there's a real company behind it, or a real developer behind it, and they actually pre-submit the app to us, and then we just have someone test it.
Is that how it always be, or will this be?
Our goal is to not always be like that, but in order to get rid of that, we have to be able to put some more protections in the system, and we are working on it. I'm writing a document right now on it, as a matter of fact.
So we have custom hardware that we use a kernel driver to talk to. It's not really system software, it's UI software, but is there any way to talk to kernel driver from a desktop bridge app?
Sure, it'll talk to the kernel driver just like it always did.
Okay.
So related to the last demo, if I have a desktop app that's running in a x86 ISA, and I want to take and now convert that to run on an ARM ISA, what are the prospects of that happening?
Well, so if you get to step 5, then at that point, the UWP tooling already supports ARM. So you just have to pick to target ARM and you're set.
And how does that relate to the recent announcement in WinHEC about Windows on ARM?
Well, so Windows on ARM actually has a translation layer that lets you take your x86 code and run it on ARM, and it basically does some on the fly.
Well, I know there's some emulation in there, but I assume that there's also from history a lot of stuff that's already been converted to run natively on ARM.
There really isn't that much.
I thought when they did
software.
I thought when they did the original Windows Phone stuff, that all the core of the operating system was converted for ARM.
In that world, the operating system is running as ARM.
Yeah.
Right. So it's the whole operating system is. What did you say? Okay. They said there's someone that if you talk to Andrew, he can put you in touch with someone on that team that can talk about it some more.
Okay. Thanks.
Great. Thanks.
It's around the click once. Is the click once get supported on the converting through a UWP?
So I know that we've had people successfully convert a click once app. I'm not sure if we've added the support in the desktop converter yet to actually do it seamlessly for you. So actually, in general, a click once app is pretty easy because it's already kind of like a directory, and so it doesn't make as many assumptions as most installers do. I know that we've been looking at adding a feature, like a flag that says this is a click once app, so the converter could natively understand it. I don't think we've done that yet, but you should go up to the booth and talk to them, and they should try your app and see if it works.
And just a follow-up question on the container. The click once uses its own app folder container, right? So is that work as is with the converter, or is going to work around the UWP?
What ends up happening is that your app is now in the new model, and so it gets its own directory just like it didn't click once. That directory is in a different location.
Okay, thank you.
So you talked about kind of the one-stop conversion initially. You didn't talk about servicing. So when I make an update to my app, how do I deploy an update to that through this mechanism?
So what ends up happening is when you do that conversion, it doesn't modify any of your binaries. It basically creates your manifest for you. It creates the little Hive file that represents what your installer did. And so at that point, if you're not using any of the tools, if you're using any of the tools that I showed, you don't ever do the conversion at all. If you're not, Visual Studio has a project that lets you take all that information and create a project that spits out the AppX file. If you don't even want to do that, you can literally just look at the directory that's created and just keep replacing your binaries and repackage it. The platform's intelligent enough that it automatically does things like block level diffing, and it does all the deployment operations for you. But we don't actually expect people to keep, I mean, you could keep running the converter over and over again, but it seems fairly wasteful, especially if you have some kind of build system. But once you have the results of it, you know what your app looks like at that point.
So even as the app runs and it writes to these virtualized registry keys and so forth, then you deploy, an update. It's smart enough to know that it's not going to blow away those modified, reg
Correct.
keys and that
Yeah.
kind of stuff. Okay.
Yeah, the platform handles that for you automatically.
Cool. Thanks.
Yep.
Hey, I'm really happy with the bridge as it is today. Works super well for me. The one thing that kind of is difficult is that every single time I try to use one of the UWP APIs, I very quickly hit those walls that seem like people didn't think about fully. Like you showed live tiles as the #1 feature, but you can't call create secondary tile. That just doesn't work. Or
So
like notifications work, but you can't get notification events, which makes things very difficult.
Yeah, the big challenge has really been anything that's going to float UI, which a lot of those APIs under the covers have to float UI. You should check, because we've been going through and adding, there's a little pattern we have to add. Like basically, the way that it works in UWP is you just call it from a thread. There's a window, a core window associated with a thread, so we know where it is on the screen. In a desktop app, you could have one thread. You could have 47 windows on 8 different screens. And then if you call some API and you don't tell us which one, we would just put things in random places on the screen. And so there's a pattern where you can basically, usually for those APIs, you can call and query, you can QI for a COM interface, and then you can call it and say, by the way, here's the H-wind, use this. We've been doing that for most of them, but I know there's still, you're right, there are some, but you can assume that we've been, for all the ones that people have been giving us feedback on, we've been going back and adding it. The user voice is a great place to go and file those things. I can tell you right now, there are actually teams of people that go and scan all of that data, and they put together, and we get weekly or monthly reports. Here are all the top asks. So if you have asks, I would go be posting it there so that we know that we missed something.
Okay. The notifications team, lifetime team is, so they'll be able to
Yeah.
That would be sweet.
For any of these things, it's always great. Go up to the booth at any time while it's there and give the feedback there as well, because that is something. It also might be that we have since added it and we didn't advertise it, and so it might be there and you might not know.
Okay, thanks.
So let's assume I'm creating a game which runs at 120 FPS on desktop. Okay, and I'm stop at step 4 where I'm using the app service to talk between Win32 and your UWP. Do you think there will be impact in performance?
Only if you needed to talk to it to paint a frame, right? That's really where it wouldn't be such a good idea. But if, for example, if it was just periodically fetching other information, I think it would be fine. But if you said every frame, and you said 120.
Well, I'm looking for a mixed reality portal, right, on the creator update, which runs on Win32. But your holographic shell is in Win32, right? The HMD devices, not HoloLens. So if I'm using the UI interface on mixed reality portal is developed using UWP, but my backend is Win32.
Right.
Is there impact of IPC call?
I think there. I mean, if you were trying to do 120 frames a second, right? That's what, every 8, like less than 9 milliseconds. You were trying to do round trips, trying to fetch data. I think you'd probably have a problem. So you'd have to look at it. But you should probably, again, go out and talk to the booth and see. I might even be up there later. We can talk about exactly what you're fetching from there.
Okay.
Okay.
So we do an audio app, and we do a lot of multi-processing and multi-threading in it. Are there any limitations in the UWP model for like an app like spawning like many threads and worker threads?
No, actually, I mean, it's the UWP apps can spawn as many threads and do all those same things.
And they respect the thread priorities and all of that stuff?
Yeah. I mean, it's still just the Windows schedule under the covers. We don't have a different scheduler for UWP.
Okay, so you mentioned that you could load libraries in process, right? So when you load a DLL in process, does that DLL have the same access rights as a normal desktop app? Like, can it do I/O controls and things like that?
In your desktop bridge process, yeah. What I had said was, you can't deploy a DLL that then gets loaded in some random processing. That's the thing that gets blocked. But if there are, like for example, if you think about Office, you get Office from the store. If there are Office like plugins installed in your system, Office will see them, load them, and they'll work just like they always did.
And auto process, so you said you couldn't call create process, right?
Desktop bridges can always, I was saying for UWP. Desktop bridge can always call create process.
Awesome.
Yeah, desktop bridge works, like I said, think about Office. Office definitely calls create process and code create instance and a billion other things. We actually use the desktop bridge. We converted Office without telling the Office team. Then we went and gave them a presentation on it, and they said, ooh, good, that sounds like, oh. And I said, by the way, this whole presentation is running on Centennial Office, or Desktop Bridge Office. So.
Awesome, thank you.
Hi, I just have a question. The case, for example, you have customers with your Win32 application already installed, right? And you want them to get the new version from the store. Is there anything special that the converter does for us, or do we need to handle that?
Well, it's not what the converter does for you, but basically we have, I think, do we have a white paper on the conversion yet? On the upgrade. So if they have the MSI version installed and then they go and get it from the store?
Yep.
Okay, there's a blog post on it. We have kind of a set way that, like, if they go get it from the store and they launch the new one, that the old one can go ahead and clean up the old one. And just so you know, because your desktop bridge app is still looking at the regular system, any of the app data that you had installed previously or had been generated previously, any of the registry keys, they'll still all be there. But you should go read the blog post. It should tell you exactly how to handle that situation.
Right, because the user can still go and uninstall the previous uninstaller, and that will delete the existing databases or whatever the App Store application might need, right? So
sure, but as long as you have installed, as long as they've installed and run your existing one, the blog post will explain the process for doing that.
Thank you.
Hi. I have around 30 big fat client applications.
Sorry, what?
30 fat client applications.
Okay.
Like trading, portfolio, research applications in the enterprise world. All of my clients sit in office. We have 4 monitors, and they work really in enterprise. They're not into the small things.
Yeah.
So I have 2 questions. We lived, according to your life, from Software City, Happy, currently.
Oh, you know my
Apex.
history.
Yeah, I know. That's why I'm coming to you. You
Okay.
trained us to go this way, and then right now we have Happy sequencing and deploying, and everything is working fine.
Uh-huh.
Now the question is, do we really need to move to a UWP?
Well, so my opinion of what's going to happen is over time, your customers are going to move to Windows 10. And by the way, the uptake that we've had in enterprise for Windows 10 blows away every single other version of Windows we've ever had. And the #1 reason that all these enterprises give us is security.
Yep.
Right? And so over time, the enterprises are getting smart to the fact that these apps are endangering their business. And so they're trying to, they're trying to get to Windows 10 as quickly as they can, which gives them a bunch of security benefit. But the next thing that's going to happen is they're running all these apps that are, effectively still running full trust. I don't think you're going to have anything urgent, like in the next few weeks, but it's the kind of thing that, another great example is the Windows Store for Business. If you want to be able to sell your app in the Windows Store for Business for your enterprises, you won't be able to do that with AppV. You'll have to use the desktop bridge or finally get to UWP. But for that kind of scenario, the desktop bridge is a great waypoint to start the process because it's already supported by SCCM and MDM in Windows Store for Business, and it's supported everywhere. So it's a really great way to just say, hey, customer, regardless of how you deploy and manage your apps, here's a single package that will work for all of that once they're on Windows 10.
Okay, a follow-up question is there any changes on API sequencing in Windows 10?
Excuse me?
Is there any changes to API sequencing for Windows 10?
No.
Good, thank you.
Will Centennial apps run on the Windows runs on Snapdragon, the one announced in WinHack?
Yes.
It will run. Yes. So how will the Continuum for Phone work for this?
Well, so it doesn't, right? Because again, Continuum for Phone is not desktop. It's phone painting a bigger screen.
Yeah.
In order to run in that, you'd have to get to step 5. You'd have to get all the way through the process to be UWP.
But Continuum apps will run on the Snapdragon. That means it will run on those phones.
The Snapdragon, like that announcement, and you should probably go up and talk to the team. And again, I don't know where Ender is, but he's back there. He could probably point you to the team. But that is desktop Windows running. And so that runs UWPs, obviously, and then it also runs desktop apps. And so that's why Centennial works on that.
Okay, thank you.
Hi, so you noted in a previous answer that you can talk to your kernel driver from your app. Do you have like a delivery pattern you advocate? Because you can't deliver the kernel driver through the store, and the customer needs to kind of go to 2 places. So
well, so just so you know, this is what I said. So in that particular case, it was a piece of hardware, right? And the correct way to deliver your drivers for your hardware is Woo.
Sorry?
Right? Windows Update.
Okay.
So you through the what's it, the WHDL or whatever process, you basically submit your drivers to Woo. They plug the device in. The drivers just automatically get installed.
Okay.
What I said was, if you're like, oh, I have a driver because I'm antivirus and I just want to hook the kernel, that's not Desktop Bridge for you. Okay. But for the hardware stuff, you just submit it to Microsoft. They plug in the device and it delivers it.
Okay. Thanks.
Hi. I currently have a suite of applications, and they have different installers.
Yep.
But they do share some registry information. So if we use a Desktop Bridge, will we have to rewrite our app? Because they'll all be kind of put in different containers, I'm assuming?
You have 2 options there. You can put them all in one container, right? And so it would be effectively one AppX. If you want to have a bunch of different AppXs, here's an example of where we had this really great best practice that we never really told you, which is using the registry as like a way to communicate between apps is just a bad idea. For a whole bunch of reasons that I don't have time to get into. But basically, if you want to keep them as separate apps, we would expect you to update that code to not use the registry as the repository. But if you wanted to keep using the registry in the short term, they'd have to be in the same AppX.
Okay, and follow-up question. So what would you recommend as the way they talk to each other?
Well, it depends on the kind of data that they're sharing. If it's runtime, some kind of inter-process communication mechanism. If it's like a data store on disk, I mean, SQLite is a really nice data store for that basically the entire industry uses, right? I mean, if you write databases on Android, iOS, Linux, everyone mostly for apps use SQLite.
Right, because right now we're doing something fairly simple. It's just as one app installs, it will put information about where it's installed so the other app can launch it. So.
Oh, you don't have to do that, right? So in that world there, don't do that at all. Okay. There's one of the features we have is called the app execution alias, right? And so you declare in your manifest, if someone anywhere calls create process on foo.exe or bar.exe or whatever the name of your exe is, just launch.
Oh, okay.
And the system handles all the rest of it for you. Everything launches correctly, everything works correctly, you don't have to do anything.
So what would I look up if I wanted to read about that?
App execution alias, one word.
Okay, great, thank you.
So I guess we've already established that for AV vendors, you're kind of out of luck in terms of converting your app to the Windows Store. But for vendors that want to take advantage of being in the store and the scale and all that kind of fun stuff, what do you suggest for AV vendors to do?
So we've actually been talking to a lot of AV vendors right now and trying to figure this out. I've been working with the kernel team, trying to figure out how can we have a safe way for antivirus vendors to do what they need to without just completely owning the system. I don't have a great answer for you today, There have been discussions around having the management UI be delivered through the store and still have to go and get the drivers and everything from somewhere else. Stay tuned. It is something we're actively looking at, and we're doing our best to try to figure it out. It's just really hard because, like, you know, on a bunch of our platforms like Xbox, we could, if we allowed you to do anything like that, we would immediately not be able to run any AAA games anymore, right? And so we can't, like, Xbox can't give up its AAA game story. But we're looking at it, and if you're any one of the antivirus vendors, you probably have contacts within Microsoft.
Yeah.
Use those contacts. It'll get back to us, and we're actively looking at it.
Okay, cool. Thanks.
Great. Thanks.